talk to you guys about senior design. He's one of the outstanding mentors for faculty and students. Now,
if he's going to say nice things, hang on.
his native language is Scottish.
No, English.
Which
No,
is
it's still
English.
English.
Okay, English. My native language is Greek. Now, in case you do not understand everything he says, I'm going to be down the hall. Come and get me so I can translate.
He's my translator.
You understand? He's been here 34 years. I've been here 36 years. You can't find a better guy. I'm serious. Now, the reason I'm saying that because I had some pizza. So I got to pay back for the pizza.
And we're both very happy now. Our blood sugar's high. Yeah!
How is it English? Okay?
Okay, yep. Everybody got it? Yep.
Understand it?
Everybody got that? Hey! All right. Thank you, Professor Balanis, for that. Excuse me. Thank you, Professor Balanis, for your great introduction. Thank you. Thank you. Thank you.
St. Andrews is where golf was found back in the 1500s, right?
Yeah, and Professor Balanis played in the 1400s. He did, yeah. Or is that his score? Oh, burnt. Yeah, burnt. Yeah, burnt.
Come and get me in case you have problems with it.
What a man, what a man. With colleagues like that, what can I say? Or with friends like that, who needs enemies, they say. So, welcome. I'm going to give you a little overview of the old senior design stuff. How many of you are going into senior design in fall? Oh, you're mine. You're mine. So we do have, just so you know, we do have two sections. Jim Aberley runs the lesser section. You're in the good one. Awesome! Yeah, excellent. So, who's that? Yeah, who is that? That's that Palmer Lucky guy. Do you know who he is? Anybody? Senior design guy or something like that? No, he's the Oculus Rift guy. He was the guy that invented Oculus Rift. If you read his story, it's really interesting, because he quite literally had this idea, ended up taking a couple of old cell phones, kind of taped them together in a cardboard box. No, I'm serious, and experimented with it. It was a nice, cool little project, he thought. Started getting some momentum. He thought, hey, I could make a business out of this. Mr. Lucky is now very lucky. He's very wealthy. What's the difference between him and you? Seriously, what's the difference between Mr. Lucky here and you?
There's nothing.
Nothing. There's no difference at all. Absolutely none. No difference. You're him, he's you. It's literally no difference whatsoever. Hey, what's this? Symbols for money, yeah. And everybody thinks they understand money because we all use it in some way, shape, or form. You really need to understand more than what the symbols are and more what you think money is. You need to know how it works and when it works to be good engineers. Oh, really? So it's not just Maxwell's equations? You need to know net present value and stuff like that? Yeah, because if you don't, you'll end up working for some business guy. And you know what they call business here? It's a good school, by the way, but it's a very good school. But it's like post-engineering, and sometimes engineering is pre-business, because we send all our rejects there. Oh, yeah, burnt. Okay. All right, what's this? It's a hardware store, yeah? What's that little R there? Registered trademark, yeah. Believe it or not, that little R turns this shape into intellectual property. Why do you care about intellectual property? Again, if you want to be engineers, you have to know about this. Why did I pick this one in particular? Because it has the word value in it. What does value mean? Value means something. It's a characteristic that makes people want or need something. It's what emerges from want and need. Value is not how much something is worth. People often confuse the terms of value and worth. Value really relates to some quality of something that people want or need that they're willing to pay money for. Again, engineers have to understand that. What's this? The Volkswagen symbol. Volks for people, Wagen for cheating people. Okay? Ethics. What happened with these guys? Yeah, they were cheating emission software and stuff like that all over the world to make their diesel cars look good. And apparently everybody knew, and it was an engineering thing. It wasn't like some business dude that twiddled a knob or something. No, this is an engineering thing. Engineers can ruin the world if we don't behave. So, why do I show all that stuff? Well, that's a flavour of some of the things you'll actually see in senior design, because I call senior design finishing school for electrical engineers. Now, if you're British, like what I am, you'll understand what finishing school is. Finishing school is typically what elite and polite young ladies would be put through in order to present them to society, to make them ready to go out there. Well, finishing school for engineers kind of follows the same thing, except we don't really talk about deportment and etiquette as much as all of the stuff you need to know to be successful in your profession, beyond the technical stuff. At this point, you should be relatively good technicians. Okay? If you're not, you've just wasted 3 years, 4 years, and lots of your parents / your money. Okay? Senior design goes way beyond this. Way beyond it. Now, I'm not going to go through all of these because there's a lot of stuff, but just so you know, our profession, engineering, and specifically electrical engineering, demands certain things of us. Okay? Now, these have been codified and they've put into some, fairly pithy little statements by ABET. Anybody know what ABET is?
Is it accredited?
That's the one. They're the guys that accredit your degree. Should you care if your degree is accredited? Yeah, because if it's not, it's crap. Basically, it's worthless. Okay, you need that accreditation. But in order to get accredited, the degree has to follow certain things. And it has to have certain outcomes of you folks. And they're pretty simple, actually. Things like, hey, you have to be able to solve problems, right? Use all your smartness to solve problems. You've got math in there and science and stuff. Okay? Apply engineering design to produce solutions. That, interestingly enough, and you'll see there's a whole bunch of stuff in this one, there's a lot here that meet specific needs, a consideration of public health, safety, welfare, global, cultural, social, environmental, wow, really? There's a lot of externality in what we do. It's not just making a thing to do something. We have to satisfy a lot of other criteria as well, as a practitioner of the engineering profession. Communication. Would it surprise you to know that most projects fail not because of bad technology, not because of bad science, bad engineering, but because of bad communication? It's all over the place. It's remarkable. From aircraft where the cables won't fit down the holes because of bad communications, to spaceships that crash into planets, again because of bad communications. I mean, it's astonishing, really, how poor communications. Clearly, important part of the profession. Ethical and professional responsibilities. This comes back to the Volkswagen thing. And I pick Volkswagen. I pick in Volkswagen, not because I particularly hate Volkswagen. It's just a great current thing that that still won't go away, basically. It's still there. But, again, you were coming back to this. Oh, my goodness, look at this impact of engineering solution, global, economic, environmental, and societal context. What does what you do to the environment? To the ecology of the planet. Okay, it's all in there. Function effectively in a team. No, you say. I've been perfectly happy stuck in the corner of my bedroom, clattering away in my keyboard all of my life. I don't need to work in a team. Yes, you do. I guarantee you, to be an effective engineer, you will work in a team, period. Okay? That's demanded of you, and it's in our curriculum. Develop experimentation, interpret data, engineering judgment, draw conclusions. Again, this is all part of your, assembling your knowledge together, making it work in a way that's useful and impactful. Okay? Number 7, the last one, pleased to say. Ability to acquire and apply new knowledge using appropriate learning strategies and the likes. So it's not just a question of saying, okay, my brain's full, I'm ready to be an engineer, done. No. You constant, continual, lifelong learning. Again, required of the profession. Required that we make you understand that as part of your degrees. Okay? Now, this is what ABET demands. Where did they get this stuff? Did they just sit in a room, a conference room somewhere and go, yeah, societal, blah, 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 global, blah, 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 blah. No, the profession told them that's what they wanted. The national academies, the profession, the professional societies all said, this is what we want of people coming out of schools. So therefore, accredited degrees should look like that. What do employers want? Well, clearly they want you to be technically competent. I mean, clearly, you've been through an engineering degree, you should at least have some idea of being able to solve a third order differential equation whilst standing in 1 foot and singing the national anthem or something, I don't know. But they want stuff that are very, very soft skills oriented these days. And it's almost like these are the things that are going to basically differentiate between you and the other person that's done exactly the same degree and got exactly the same GPA. Number 1, communication. What a surprise. Can you communicate? And this isn't just a question of can you write a technical report. This is, can you communicate across disciplines? Can you communicate across education levels? Okay. Problem solving, again, no surprise there. It's embedded, both of these are embedded in the ABET requirements. Interdisciplinary environments, again, you will never, I guarantee you, work solely with engineers in a solely engineering context. There will always be other disciplines in there. Working at and with multiple states, this is an interesting one. Can you handle working with people that are not even in the same country, maybe not even on the same planet these days? It's an interesting one. And this one down here, being aware of the business context. This is a biggie. This is absolutely huge. Although it's ranked number 5 in this survey, you'll find that nowadays, you being aware of the kind of business context, aware of why it is what you're doing, what you do, being aware of where money comes from, where it goes, how it's used, becomes really, really important. So, in senior design, we try and capture all of the above. All of that stuff. Okay, it's our last chance to do it, but it's our best chance to do it. It's our best chance to do it for a number of reasons. Number 1, you're all trained, right? You're all technically trained. Number 2, you're all mature. So you're ready for this stuff. Number 3, you're about to graduate and go off into the world. You should be motivated to know this stuff because you're going to be successful if you know this stuff. So it's an ideal time to do it. So you're going to apply stuff that you learned in various classes at this point. You're going to learn a heck of a lot about the soft skills. Okay, and you're going to apply them. And of course the business context. You're going to work in teams. That's an absolute mandatory one in senior design because again it reflects ABET requirements. It reflects what the employers demand. You're going to, and I'll come back to this, you're going to be supported, quote unquote, by a mentor as part of this. You'll be in teams supported by a mentor, working on a project. But you're going to answer to some customer. Now the customer can be various entities. It might actually even be you. You could be your own customer in this. Or maybe someone else, maybe a company, maybe a faculty member, maybe a graduate student, maybe someone that you found out there who's really interested in a solution that you're willing to offer them for a particular problem that they have, a particular want or need that they want satisfied. You're going to write reports and you're going to give presentations and you're going to communicate instead of taking tests. You won't sit down. There is no senior design exam. Yeah, we may give quizzes just to make sure you actually show up to the classes, but there's no exams. Okay? And you're going to produce something absolutely awesome. And what does something awesome actually look like? Yeah, what does something awesome look like? Well, let's see if this will run. We can get it to run here. Oh, what's happened to the, is there no audio on this? Oh, that's so disappointing. There's no audio. Weird. Well, let me narrate then. Oh, it's not even on the screen. That's what the problem is. Oh, I get it. Okay, give an engineer a laptop and what happens? Disaster. Let me see if we can get this up here. Sorry. Oh, here we go. Right, so, right, now let's run here. So here's some Fox News. And I don't know why this isn't playing. This is kind of weird. Oh, well. So anyway, this is, Fox 10 came along and had a look at one of our demo days in which we showcase our stuff. And they came along and, sent a reporter to chat with some of the students and look at the Chiron down there, cool inventions by SU seniors, very cool, yeah. Yeah, look, light bulbs, yeah, we do light bulbs, yeah. Anything that has flashing lights, very popular, very good, yeah. Oh, look, circuits and stuff, nothing's on fire, that's good. Yep. Nerdy guy with glasses, yeah, cool, yeah, good. Yeah. This is the best one. This was the graffiti bot. It was an automated graffiti machine that went and sprayed walls with symbols and stuff. Awesome. Automated irrigation system, yeah. Can't even remember what the heck that was, but I mean, so look at that. Look at that. I look younger now, don't I? I look younger. Yeah, I can't imagine why. And what this guy is saying is, your students are terrible. I wish we had better ones. Hopefully they'll be better next year. So, that kind of stuff. But yeah. But it was fun though. It was definitely fun. But that's the producing something awesome side of things. But let's carry on here. Yeah, right. So, interestingly enough, the class is kind of a little kind of bipolar in the sense that 50% of your grade is kind of technical. You're basically really more on how well you plan and execute your project in that sense, not necessarily how complicated the equations are that you use for it, whatever, and how cool your product or service is. And 50% is for communications. By the way, and again, on the communication side, it's how well you communicate with us, how well you communicate with your customer, how well you use things like general kind of reporting and technical reporting and social media and things like that to get out there to do customer discovery, that kind of stuff. It's all in there. And as I say, it culminates in Demo Day, which is this kind of final kind of trade show. This year, it's on the 26th of next month. We're going to hold it in the Student Pavilion. We'll have everybody there at once rather than splitting it up. Cheryl McAfee up there is doing a wonderful job of organising absolutely everything for us. We're doing nothing, thank you, Cheryl. So hopefully it'll be awesome. Of course it will. Okay? As I say, everything leans on these soft skills. For those of you who don't know, it is a 2-course couple, 488, 489. For you guys, obviously, you start in the fall, you finish in the spring. You must do it consecutive. You can't just pick and choose when you finish. If you start this fall, you finish coming spring, you don't get to break it up because you have to stay in the same team with the same project. And if you don't, you have to retake 488, I'm afraid. It is what it is. But in general, the kind of split between the two is in 488, you actually kind of get going, or you get plenty of time to get together, get your projects, get your mentors, your teams and stuff like that. Start researching, start planning, start doing the kind of general design work, and pretty much get everything together to get you into a position where you can do something, you can make, you can execute. Then in the second semester, you execute. You do your thing, you get it going, you build it, you test it, you refine it, and then you present it out to the public. I mean, to be honest, there's a lot of kind of bleeding either way where, some building goes into 488 and some design work spills into so we don't care about that, but these are the kind of general requirements of 488 and 489. Okay, as far as the teams are concerned, I'm trying to focus on the questions that I get asked most often. Typically, we're talking 4 members. Some 3 and 5 person teams may be considered, but only if the situation warrants it. We've got teams that are completely on campus, we've got teams that are completely online, and that works, believe it or not, works fairly well. And we've got what we're calling hybrid teams where, we've got 1 or more people online and the rest on campus kind of thing. And those are kind of interesting. They seem to work fairly well. I mean, we welcome any and all of these configurations. Pretty much get a month to get together and your teams overall, maybe a wee bit more than that, so you've got plenty of time to get that. But you can start thinking about these things now, pleased to say. And as I said, you have to keep your teams together. Really, we do not form the teams for you. And again, this is another question that comes up. We don't just randomly or arbitrarily assign people into teams. That's not going to work for a number of reasons, even though it may be reality. You know, in industry, you're going to be told you're working with this guy, even if you can't stand that particular person, but that's life. At least in this case, you know, a lot of you already have little cohorts that you like to work with. Good, we're not going to split that up. I'm going to let you do that moving forward. As far as making these teams, we'll be on Canvas next year. If you've not already seen that, you're going to enjoy the delights of Canvas. Basically, be able to advertise your skills and also, you know, advertise for people for an existing team on Canvas. And, you know, you can form around a project, or you can form a team and a project can emerge from a team. You know, we're very, very flexible as far as that is concerned. The project mentor, important thing about the project mentor is that it's basically someone who's going to help you, really. You have to have a mentor because ultimately they're going to have to present you know, a grade to me at the end of the semester for your technical competence and your kind of technical, quasi-technical skills. We're typically talking about an EE faculty member or someone from industry who's a professional can mentor. Even professors from other universities have done it before. Right? There's a wide range of people that can be a mentor. Some mentors will come to you with project ideas, and you know, you might form a team around that. Other mentors are happy to support you in your project and your ideas. No problem at all. The mentor is going to supply 40% of your grade, and in my section, we, meaning the TAs and I, supply the other 10%. That's a bit of an unusual one and maybe slightly controversial because what we use that other 10% is for balancing. And basically what it means is clearly if we have, you know, currently we have 56 teams. 56 teams. If we have, you know, one team that's basically built a fully functioning space shuttle and orbited Mars with it and is executed perfectly, they're going to get 10 out of 10. Right? If we have another team that basically has two pieces of wire, a battery and a light bulb, and have failed to light the light bulb, they're getting 0 out of 10. Do you see where this is going? Does this make sense? Okay. Regardless of how awesome your mentor thinks you are, we've got that 10% to kind of fairly balance. Because we get to see everything. Yes, sir?
Is it one team per faculty or kind of faculty members?
Actually, we have faculty members mentoring 5 teams sometimes. And by the way, one of the interesting things we'll be doing is, just so you know, an experiment that I've run this year is being adopted college-wide, and that we'll actually be hiring people to be professional mentors from industry, which is going to be kind of cool. Yeah, I'm really proud of that one, and as I say, it's yeah, I know, I'm good. I'm so good. And that's, to be honest with you, I mean, some people would rather work with faculty they know and love, if you know any such people, but others, you know, would rather work with industry people, because again, you know, they maybe have a better feel for what's required in industry. You know, it's up to you. It's up to you. So you find your own mentor though, and if you're interested in faculty mentors, you just go on the EE site here, you know, SE, you know, School of Electrical, Computer and Energy Engineering site. So you can see people with various interests. Everybody's eligible to mentor unless they're on sabbatical. Of course, then they might not be able to actually mentor you, but everybody's eligible. So, and you may think, well, you know, maybe I want to pick a mentor that is an expert on the subject that I want to do for my project, and maybe you don't. I mean, it's completely up to you. Sometimes that's a smart move. Sometimes you don't need it. Sometimes you're the expert. You know, we have musicians that come in and want to do, you know, sort of musical effects and stuff like that. And yeah, we have signal processing faculty, but maybe the student actually knows more about the, you know, the music stuff, and actually maybe wants a mentor in a different area to help them with kind of business-related stuff if they want to spin it out in some way, make a product. Yeah, that's all perfectly legal. Mentorship, as far as we're concerned, can be anybody as long as they're professionals and can mentor you accordingly. Mentor isn't your boss, just so you understand, but they are required to grade you. And of course, we help them with that. And as I say, in many respects, your mentor is kind of like your spirit guide, your moral support in many respects. Kind of keep you motivated, keep you going. as in not necessarily, certainly not your boss, and not necessarily someone who's going to solve every technical problem for you. You're supposed to be solving the technical problems. As far as the projects are concerned, the kind of 4 things we pretty much demand of projects is, it has to be open-ended. Okay, there is no distinct single solution that you can go and look up in a book for this. It's very open-ended. Okay, it should be challenging. In other words, it's not just another class project. It's something that's going to actually challenge you. You're going to have to learn new stuff. You're going to have to do a lot of research. You're actually going to have to stretch yourself here. And obviously, this thing here meet a societal need or want. We do talk about this human-centric design kind of process, where basically you look at people and what they want or need. Look at society and what they want and need, and you try and fit your projects to that. Okay? But at the end of the day, it's going to be value-driven. There's going to be some value proposition behind it that you can articulate as part of your communications. Okay? Again, value meaning fits a want or a need. It's not just out of curiosity, and there has to be a definite want or need at the end of it. Okay? Be great if it could integrate as much of your learning experience as possible. I mean, that's fantastic. Well, obviously not everything, but multiple elements, and as I say, learn new stuff. You've got to be careful here. We don't have infinite resources. You don't have an infinite number of people. You have your 4 team members. You have your mentor, and maybe some of the graduate students if it's a faculty member, or an industry. They might be able to hook you up with a technician, hook you up with some some equipment, or some other engineers that can consult with you. But that's about it. You don't have infinite numbers of people. You don't have infinite amounts of money. We give you $100. Yeah, I know. A whole $100 to do these projects. I'm glad to say there's also other funds you can tap into that go up to several $1,000s, but you're guaranteed $100. Okay, which is awesome. Which should not be spent on pizza. It's actually for like comparts and stuff like that. But it's not infinite amounts of money either. And clearly you have 2 semesters to do this. So when you're picking your project, the thing about the space shuttle, launching it, flying it around Mars, it's probably not going to happen in 2 semesters with $100. I mean, call me a pessimist, but I don't know, okay? And as I say, make sure your project actually is cool, is challenging and cool. And we've seen a lot of them that, you look at them and you go, oh, seriously? I could have done that in a weekend. And if anybody's going to point at your project and say, I could have done that in a weekend, it's taken 4 of you to do, 2 semesters to do it, man, you should be ashamed. You really should. And I think you'll probably know where I'm going with that one. Project resources. Really try and use, as much as possible, design from the ground up and only use off the shelf when clearly it's economically and like time-wise, resource-wise, more sensible to do so. We've got a ton of stuff you can use here, by the way, in terms of development kits, dev kits for, and components and stuff. Just gigantic amounts of stuff you can use, as well as software. Of course, we've got tons of software you can access, and labs and facilities and things like that. And of course, if you need a case or a particular mechanical contraption to make your project work, we've got 3D printing, we've got machine shops and stuff. And we actually have a gentleman that this year I managed to get the dean to pay for to be kind of like the centralized resource for all the resources. So his name is Matt McWhorter, and you can go to him and basically say, Matt, I need a printed circuit board made. What do you recommend? He'll say, well, you go to this company, and etc. Or I need to have this hole drilled to this tolerance. Well, I'll go to the machine shop, and he'll be able to actually do it. And he can give you access to the open labs that you guys have done your various fiddling classes in. The open labs with the tools and hacksaws and whatever. You can go and use those too if you want. So those are part of that. Got plenty of resources. Just as a subtle warning here before I kind of go into the coda here, regardless of anything, and please understand this, I'm not trying to be mean or what's the word I'm looking for, or assholey maybe, or something, I don't know. Regardless of where the project comes from, regardless of what challenges you face, regardless of what, it's your project, right? If it crashes and burns, it's on you. You can still pass senior, I will say maybe aside, as long as the dean isn't listening, you can still pass senior design even if your project does actually crash and burn. I mean, you may not get a great grade, in fact you won't, you can still pass it, but is that what you want to take to your employer? So you're sitting there with 5 other people with 3.8 GPAs or whatever, and they're trying to decide who to hire, and they say, oh, let's ask them about their senior design projects, which they inevitably do. And one person says, yeah, well, we did this awesome system that went off and used GPS to track this, and it did this, and then the farmers knew exactly where, which valves to turn on to irrigate their fields, and we believe we're saving the water and saving the planet. And we executed it, and it's now installed in a little pilot. Oh yeah, great. And you go, I had 2 pieces of wire, a light bulb and a battery, and I couldn't get the bulb to light. You go, I think we're done here. Okay. Okay. Okay, here's the last thing I'll say. This may absolutely shock the living daylights out of you, but you think of yourselves as budding electrical engineers, yes? Yes? Like electrical engineers. What's the best kind of engineering? Electrical. Head and freaking shoulders best. Who are the most awesome people in the world? You are, of course. No question about that. But in addition to being engineers, you're also entrepreneurs. Did you know that? Everything that you've been trained to do, interestingly enough, with a little tweaking and a little addition, makes you into the ultimate entrepreneurs. Now, you may say, wait, what? Well, what do you mean by entrepreneur? You mean I'm going to be that Palmer Lucky guy and go off and form Oculus? Well, yeah, I mean, that's part of it. But even if you go and work for Intel or Honeywell or GD or whatever, you're still entrepreneurs. Okay? Because of the way you think, because of the way you act. A big part of what all of the capstones, just a matter of interest, does anybody know how many capstones we have in engineering in total? Because obviously you're one. Anybody know how many capstones we have in total? Have a guess. Just.
300.
No, I mean capstone courses, not people obviously, but capstone courses. Think of all the different disciplines, in other words.
4 or 5.
I mean, I would have said something, half a dozen, consider mechanical and so. 17. 17. I know, you think, wait, 17? Yeah, because they kind of split out some of the computer ones, and we've got information man, or what, I've forgotten half of the names of them now, but in addition to the usual engineering disciplines, we've got other ones you wouldn't think about as being capstone, but they're 17. And of course, between here and poly, that makes up 17 quite easily. And so we're trying to do things to make all of these the kind of finishing school for engineers. And a big part of this is going to be this thing called the entrepreneurial mindset. And I know it sounds really fancy. And frankly, a lot of people, to be blunt, hate this term. If you're really interested in finding more about entrepreneurial mindset, have a look at this little YouTube video. It's super short. It's very informative. But it's a very, very powerful tool for making you into the kind of engineers that we want you to be, and more importantly, you want you to be. The whole idea is we've given you a skill set. You know electromagnetics, you know power, you know solid state, you know signal processing, you know that blah, blah, blah. That's your skills, right? Mindset gives those skills, a direction. Right? So as I say, their skill set is like power, like the engine, and the mindset is the control system. It's actually going to put you in the right direction. And we're going to talk a lot about that. And it's probably not what you think it is. I'll tell you that right now. It's not all business classes and all that stuff. Don't worry about that. In fact, it's a lot about this, as it turns out. And again, if you're interested in this, have a look at this little video there, which is on your handout. It's bringing these 3 elements into all that other stuff that we have to do for the engineering profession. Curiosity, connections, and the creation of absolute unadulterated value in all of this. Okay? Curiosity. What brought you into engineering in the first place? Why are you engineers? Was it to make money? I know some of you may say, well, yeah, kinda. You're in the wrong profession for that. I could give you 10 professions right off the top of my head that make a lot more money than you're going to make, but they're all freaking boring as hell. You want to be a dentist and dig cavities out people's teeth all day? Holy crap, no way. Are you kidding? You have any idea what the suicide rate is among dentists? I mean, again, not funny. I mean, that's a bit dark humor there, but you know what I mean. No. You may think it was money. No, way more than money brought you here. Curiosity brought you here. And you can apply that as a force of nature in what you do. You wouldn't believe. Connections. You know, I wasn't a big fan of Steve Jobs. I'll be absolutely honest with you. I wasn't a big fan of Steve Jobs. And I kind of think Apple products are Satan's spawn, to be honest with you. No offense. No offense to Apple lovers. My good lady wife is an Apple devotee. She kneels down and prays before her Apple products every night. I mean, what can I say? But boy, he did something really well, and he identified what made people valuable in his orbit, and that was their ability to make connections. And what he actually said about it was fascinating as well, because I mean, he actually identified something that was superb, that people like us that kind of make connections and make something new didn't even realize they were doing it, and almost felt guilty to take the credit for it, because, well, it was obvious I took this and this and I made this and it was awesome. We do that all the time as well, and that's part, believe it or not, of this entrepreneurial mindset. And then this creation of value, where you obviously have an end in mind. You have this want or need in mind. And yeah, I think we can all get our heads around it. We can all get our arms around that. But sometimes, you know, the business context has to come into that too, so you understand what the consequences of value are. Because at the end of the day, as I say, it really kind of comes down to, do people want to pay for whatever it is you're offering? So, recap. Senior design, I'll be honest with you, I say it's one of the most important class. No, I'll say it is the most important class you'll ever take. Be blunt. Teams, open-ended projects. Team members, mentor and project. You get to select them. We're not going to force them on you. Really, 50-50. Oh, and by the way, I think you probably realize that because of the 50% communications, it does count as a, language and literacy? I always get that mixed literacy, up. Yeah. Language and literacy. Yeah, so I mean, hey, it meant you didn't have to do underwater jazz in America or whatever I don't know what the course is, but it meant you didn't have to do that. So you get, soft engineering and entrepreneurship. Questions. I'm sorry, I've prattled on way longer than I really intended. Questions? Because I think we still have, 5 minutes, yes?
Okay.
You're about to, yes, sir.
While choosing a mentor, so like we can go to the industries and
anywhere you want. We'd prefer, obviously, if they were professionals rather than your mate, your buddy, you know.
Oh, okay.
Yeah. This is Frank, he's my mentor. So what does Frank do? Well, I don't know, Frank's never told me. I think he just sits at home and smokes weed all day or something. But he's a good guy, so has to be professional. You can tell I've had experience of these mentors before. Yeah, anything you want. Sir?
For groups that do well, how early do they start to actually build their project?
So, it's funny you should mention that, because I want to run a little experiment. I like to experiment on students. So, okay, turn the camera off. I would love it if you guys had, I know this is time machine time, had gone back to when you first came into ASU, whether it's through E2 camp or, and started thinking about your senior design then. Why? Because who knows where it could have gone to? And by the way, in terms of resources, one resource I didn't talk about, I talked about the $100 and some other money that's available to you for projects. For entrepreneurship, this campus, I mean, you literally are stepping across giant piles of money in this campus for entrepreneurship, for spin-outs, and seriously. I mean, it's just wacky. This place is, the #1 in innovation thing. I know we all tend to make jokes out of it. Like my daughter, who's a student here, she comes across, you can't get a top off, so she says, I'm going to innovate the living daylights out of this thing. She's #1 in innovation. Yeah, exactly. Yeah, but I mean, there's a lot of money for really entrepreneurial stuff around here, which, and I mean, if you start super early, I mean, you can get all sorts of, you know, tap into all sorts of things like that. By the time you get to senior design, if you do decide, gosh, boy, this is potentially a gold mine, you know, Blockbuster, it's Oculus Rift, it's whatever, it might be a wee bit too late for it. I know it's sad, and that's why I'm hopefully with the ASU, was it ASU 101? I want to, so oh, the dean said it was okay, by the way. Yeah, the dean said it was okay if I experiment on students and get them to start thinking then. And I know that's a weird answer to your question, but what I'm going to say is the earlier you get started, you know, thinking about projects and get going on teams, generally the more you're going to hit the ground running and the more momentum you have. I'll be honest with you, it doesn't always happen. As you might guess, we have had teams that have started, you know, start a summer and they get going and they kind of run out of steam halfway through the first semester, and you can see it just goes it's like the air comes out the balloon, and it's not all the time, but I'm just again, you have to be careful because you do have other things you have to think about, obviously, like getting a job, like graduating, like not crashing and burning or whatever other courses you have to be doing. You know. So I mean, but the earlier the better. I mean, like anything in life. Yeah. Questions? Yes, sir. And oh, I'm sorry. Forgive me. This gentleman here was next, and then this gentleman in the green. Yes. Sorry.
Okay. What if you come up with a project, you select a team, you mentor, and in the middle of the semester you realize that the campus or somewhere else they design the same project,
or some other reason why you can't do it, or something like that. I'm not so worried about, you know, the kind of duplication thing. To be honest, as you probably guess here, I mean, yeah, we are looking for awesome stuff because it's going to make you feel good, it's going to make your employer, but the process is as important as the product in this for senior design, because we're trying to hit as many of these requirements as possible. But you know, there's something we call pivot. I mean, what everybody calls pivot actually, where you have to know when and where to pivot in any project. And the whole idea of pivoting, of course, is that you come up to a insurmountable roadblock, and you have to either press the reset button or at the very least, you know, hard right. You know what I mean? That's okay. That's perfectly okay. And you know, there's one adage that, again, no big surprise here. You may have heard this one before. If you're going to fail early. Fail not at all. Not at all. Exactly. No, not at all. If you're going to fail not at all. No, fail early. You know what I mean? Because that way you're going to have more. You won't have burned through your resource and your time. Pivot, you know, more effectively. That makes sense. And certainly agree. Yeah.
Project that we bring.
Yes, sir. Yes. Yeah. The best projects.
Okay. So
the best are the ones that you bring to the table.
Is there like choices that to choose from, like the ASU offer or something? Or?
You can do whatever you want, as long as it has electrical engineering content. That's one of the other things that have stymied people before. They start the project and very quickly it becomes 90% mechanical engineering, 10% electrical. You know where I'm going. And again, you might think, well, okay, fine, if it's awesome, that's fine. Yeah, but then, again, it's as long as there's some electrical engineering content, we're going to let it slide, but can you handle the mechanical stuff? You know, some people can. We've had, gosh, you know, the years fly by. It's terrible, actually, but some of you may have seen the electric motorcycle that some guys did, built from the ground up. They bought a wrecked Suzuki, they took the frame of that, built an electric motorcycle. Now, how much of that is electrical, how much is mechanical? I mean, maybe you could say 50-50, maybe kind of thing, yeah, you know, with the power stuff and the control stuff and the charging and this, that, next thing. But the guy he could strip motorcycles and put them back together in his sleep, so he already knew that. So you don't want to get into stuff that requires skills you don't have, unless you feel it's going to really help you moving forward and you want to put the time into gaining those skills. You know what I mean? In other words, if you have to do another degree to finish your senior design, don't. If you can do it, you know, by, you know, sort of reading a few manuals, hell yeah, I mean, that's all part of it, yeah. But yeah, bring your projects. Obviously, we'd like to have a look at them before we say go, because some of them are, you look at them and you go, oh my God, this is never going to work. Or, no, dude, you know, there's 100 other people have already done that, and you're just not going to be able to differentiate yourself. Or so we can advise, but yeah. Yes, sir.
Is there like teams where not everyone on the team is electrical?
Oh, that's a great question, Bill. Thank you for asking that. We do indeed have teams that are kind of, okay. The norm is 4 electricals get together and do their thing. But we do have teams that, like the bioengineers will come to us. They run their capstone. It's one of the 17 capstones. They run their capstones concurrently with ours, and it's a 2-semester thing. They'll say, hey, we have 2 bioengineers, and they want to do this needle that goes in, but it does some some sensing, and there has to be like an instrumentation amp and stuff. And we're not sure about this, that we need a couple of electricals. So bang, you got 2 electricals, 2 bios. They get graded by the bio guys. We grade you. The overall project success obviously is graded by both sides, kind of as a whole. But yeah, no. So you can actually get those situations. Similarly, you can bring in. We've got teams where they've brought in a computer scientist who maybe is doing an independent study, as an example. And again, they get graded by their people. We grade you, but according to our criteria. So there's all sorts of awesome things like that. So it's a very, very good point. Yes, sir.
What if, let's say you give half the project to the bio guys, but you don't really understand what they're doing?
As long as you can articulate the electrical engineering value of what you're doing, you're safe. You know what I mean? I know what you're saying. And do you have to become a bioengineer to work with bioengineers? No, you don't. And similarly, you don't have to become electrical engineers because they never could, because you're smart. As an example. Actually, working with the bio guys is awesome. Some of you guys may already have some thoughts about bio-related projects, bioengineering-related projects. And obviously, between now and August would be a good time to let me know, so I can go to Vin Pizziconi and these guys in bioengineering and say, hey, you've got a couple of students in electrical engineering who are interested in, would this be a good joint project? And then you can say, well, ask some of our students. And then we kind of form the kind of multidisciplinary team. I mean, ideally, you can see where at the end of the day, it would be great if all 17 of the capstones kind of bled into one another kind of thing, and everybody worked in everybody else's that would be awesome at the end of the day. But clearly, we're trying to synchronize, and we're not. We have the absolute best capstone imaginable, and everybody else is down. We'll need to bring everybody else up to our level before we can synchronize. Sir?
What kind of options do we have in terms of funding and reimbursement?
We will give you millions of dollars, millions, just as much money as you could possibly spend. Okay, that was an outright lie there. But look, the $100 departmental budget is kind of like for sundries, for little bits and pieces. It's kind of like your petty cash drawer, where you have to go out and buy a breadboard. You're guaranteed, as long as you have the receipt. I mean, we have a process that you have to have a receipt and fill out a form, but it's guaranteed you'll get. And when we say 100, it's really more than 100. It's somewhere between 100 and 150 or something that we have no problem with. But say you go out and you say, hey, to do this project, and of course we have these issues all the time, I need a $500 whatever. You can get it. But you just have to be able to justify why you need that $500 whatever. You can't just say because it's cool, because it's a really nice color or whatever. If a $50 whatever is going to do, you won't get the $500 whatever, right? That makes sense? Yes, sir.
Does that get reimbursed at the conclusion of it?
So now, what we'd prefer to do, and again, the ladies at the back there will underscore this as well. We'd prefer to buy stuff for you. So in other words, you give us, once you're approved, so you basically state what it is you need, why you need it specifically, where you're going to get it, and how much it costs. Once you get the tick, which comes from me and maybe from the director, the unit director, depending on what it is and how much it is and who's involved and stuff, then if you hand the form filled out to whoever's going to be in charge at that point, used to be Jen, I don't know who's going to be, they will order it for you, ideally. If you do order yourself, you've got to be very careful not to fall in like we had one student, unfortunately, who, although we told them you cannot be reimbursed for items over $1,000, went off in his own credit card, bought a single item for over $1,000 without being approved, and then came back and said, hey, look, I got this, it was a hell of a bargain, and it cost $1,000 so many dollars, reimburse me please. And they had to be told, guess what? That's yours. You own it. Because we can't, by university regulations, reimburse for over $1,000. And the student actually was pretty cool about it, believe it or not.
Yeah, usually when you buy something over $1,000, with that much abandoned, you probably are doing more than often.
I don't know what to say about this particular. I mean, I won't point to any names or individual, but it was one of these things you begin to think, really? You've got that much money to put? Okay, fine. Yeah. Sorry, yes, sir, down here.
At the end of the capital, who actually owns the project that you have?
Oh, another brilliant question, actually. Did you know that one of the twisty things about your position at the moment as undergraduates is you own the intellectual property associated with the stuff you do at ASU. So you do an awesome capstone and it's like, wow, it is the new Oculus Rift or whatever, it's yours. Graduate students, staff, faculty, no, we sign that right away. And I should mention as well, if a company comes along and says, okay, you have to sign your IP across and you agree to that, then it's no longer yours. But anything you're thinking of right now is 100% yours.
So when you say like Oculus Rift and all that stuff, does that mean you can like actually make money off this this intellectual property that's yours?
Why not? Why not? But the trouble is you have to use what we in the trade call Kozicki's rule, which basically says that for every $10 you make on an absolute guaranteed deal in intellectual property, in other words, intellectual property like a patent or whatever that's worth something, you're going to have to spend at least $4 to get there. And you may think, well, that's a great return. That's $6 return on every 10. That's for the guaranteed ones. That's for the ones that have the highest patent rankings and stuff like that, which are very few and far between. And B, you want to make $1 million? Of course you do. $400,000. Do you have it? Right. So I mean, so for the patenting expenses and the contracting expenses and the lawyers and more lawyers and even more lawyers and the occasional accountant. So you're going to be spending at least 40% to get to where you need to be or where you want to be. I guess we should, we're over time, so I'll let you guys go. But hey, I'm in ERC 561 also. You can easily contact me, obviously, through the school site, but drop me a line if you need to know anything. I'll be happy to help. All right, folks. Oh, thank you. You're so welcome.